Hi guys, in this example we are writing and finding the equation of a cubic curve or a cubic polynomial. So what do we need? What do we have? Well, we have three pieces of information. The first piece is that this polynomial actually touches the x-axis and it also cuts the x-axis. So where does it touch? It touches at x equals -2. It cuts the x-axis at x equals 1. And on the y-axis, it cuts it at 12, at y equals 12. So with those three pieces of information, we're going to come up with the equation, the written equation of that particular cubic polynomial. But the first thing we want to do is actually draw it, put up here a sketch so we can kind of better comprehend it. And then we're going to use that formula, standard formula, to come up with that cubic equation. So I'll be right back with a sketch of that cubic polynomial. And here's that sketch over here. So let's go through it again. It cuts the x-axis at x equals 1. It touches the x-axis at -2. And it cuts the y-axis up here at 12. So now that we've got that sketch, it kind of gives us a clue of what's going to happen. I'm kind of guessing that because it's dipping first and then going across this way, it's going to have a negative constant. In other words, the a value from the formula here, if you can see that, is going to dip and then go up, meaning it's a is less than 0. It's going to have a negative kind of value up here for that a. See that a right there will be negative, but we can work it out. So how do we work this out? Well, first of all, we substitute the x values when y equals 0 into that. So let's put them in that equation. So first off, we have y equals a. We don't know what a is. So that's what we want to find first, bracket. And then we have x minus the first x-intercept, let's call it at x equals 1. So because it's positive 1 there, we write down -1 right there. Okay, where else do we have? Well, it's cutting the x-axis or touching at x equals -2. So because it's touching, it's like a parabola through there, we write this out twice or we square it. So I'm going to square it. So I'm going to bring these two together. So it's x, because it's minus, we put a plus, all squared. See the parabola on top of it? It's not cutting, it's touching. That's why it's squared. Well, x times x squared is cubed, so clearly it's still a polynomial cubic. So what's the next step? Well, all you have to do now is substitute a part that it cuts through the y-axis, and that part is when x equals 0 and y equals 12. We take these values and sub them in here in an effort to find a, that constant, and hopefully it'll be negative as the graph indicates. So let's go ahead and substitute into that. So y is going to equal 12, so we put 12 here, equals, we have the a value, and then we have x minus 0. What's x? It's already 0, x minus 1, sorry, so it's 0 minus 1. And then again, x is 0 plus 2 all squared. So let's simplify this. So we'll have 12 equaling a, we don't know what that is, times -1 times 4, because 2 squared is 4, isn't it? So 4 times -1 is -4a. And of course, on this side, we still have the 12. Dividing both sides by -4. That's going to yield us a result of a for this equation right across here. Okay, we have the -3. That seems to work because it's negative. Remember, we showed it's dipping first across here, so a will be negative, so that confirms it. So that's our a. All we have to do now is substitute it back into the equation, and this is our equation.